Hey guys, so I'm going to work out a problem by one of your peers' request. Um, it is problem 104 from lesson, I think it's 832. And it talks about polynomial behavior. It says in part A through B, or D, sorry, for each polynomial function f of x, now we have the polynomials graphed for each problem. State the number of linear and quadratic factors for the factor form of its equation. And then how many real or complex solutions it might have. And there's an example at right here for this guy over here. F of x has 3 linear factors, therefore 3 real roots and no complex. Okay, so let me see if I can write on this. Perfect. So, okay, great. Let's look at the example here. Remember we talked about in class that if you were to zoom in into just this part here, ooh, that's really thick. Let me see if I can change that. Just that part right there. And we were to black out everything else. Well, this behavior at this root is linear. So that factor right there would be linear, right? And so same deal for this piece right there and that piece right there. All of those 3 factors, or roots, where f of x crosses the x-axis are linear because they behave as a line would through those x-intercepts. Okay, so what is the degree of this polynomial? I also talked about how we can determine the degree by the turning points, right? So here is one turning point, and that's another turning point, because it turns from going up to going down, and from going down to going up. Okay, now the degree was one more than the turning points. So in this case, we have a degree of 3. And that would be, at most, how many roots it would have. Okay, if this is too fast, pause the video and yeah, and rewind or whatever you need to do. But this is just review from what we did in class. Okay, now let's look at how we can find how many real and complex solutions a polynomial can have. Now for that, I'm going to pick part C. No, not that one. Let's see. Yeah, let's do B. Okay. So I'm sure you guys can do this problem here. That root right there is a linear root because it behaves like a line, and this root right there is a quadratic root because it behaves like a parabola. Okay. So we can say for this guy, whatever that is, x plus 7.5 or whatever that is. That's just a linear factor. But over here, x minus whatever that is, a half, that is squared, a squared factor, because it behaves like a parabola. Okay. So that would be a potential equation for that. Of course, I don't know what the real roots there are, but I kind of guesstimated with these roots there. Okay, f of x equals that. Okay, great. Now, let's look at this guy. Well, first of all, let's look at the degree. The degree would be 1 plus the amount of turning points. Well, here's one turning point, because it goes from going up to going down, and here is another turning point, because it goes from going down to going up. Okay, so it has 2 turning points. That means the degree of f of x is 3. Okay, but it only crosses the x-axis right there. So what's happening? Well, what's happening here is that, by the way, this root there is linear because it behaves like a line. What happens is that this part right there just has complex solutions, complex roots. right? So if we were to say, okay, well, let's solve for f of x, if we had an equation, set that equal to 0, then this part right there would give us the complex conjugates, or the complex solutions. But it has one real, and mainly right there, one real solution. Okay, and of course, here we have on number C, or letter C, we have 1, 2, 3, 4 linear roots. And over here, it's a combination. And I'm going to let you guys figure that out. Okay, I hope these help. What I really want you guys to identify, or to see, to recognize, is that the complex solutions are given by something that kind of looks like that, right? Where it doesn't cross the x-axis, even though it should. Intuitively, that's what the complex solutions mean. Anyway, guys, I hope you have a great weekend. I'll talk to you soon.